welcome everyone to this class on matrices and determinants. So we are going to look at what matrices is all about. Then we look at the various type of matrices. So thereafter I'll move to addition and subtraction of matrices, multiplication of matrices, determinants, factors, and inverse of a matrix. So let's look at, before we achieve all those areas, let's look at what matrix is all about. The matrix is basically the arrangement of numbers or elements. We call them elements, which might be the element can be in form of numbers or alphabets, where they are being arranged in a bracket with the use of rows and columns. So we make use of elements, that is use of numbers and alphabet, to arranging them in pattern of rows and column in a bracket. So and that basically give us a matrix. So we can look at example of a matrix. So with the examples are in form of this. So this is a perfect example of a matrix. So we have the element there in form of number. These are the elements, and these are the enclosures. There is bracket, enclosed bracket. So the numbers are arranged with the use of rows and columns. So rows are basically contained in this form, and these are the columns here. So we also have another example here. So we have the alphabet being arranged in form of rows and columns. So this we have 2 rows and then 3 columns. So, and as well we have another example. This is also an example of matrix. Alright, so that is what matrix is all about. So for us to understand perfectly what matrix is, we need to get the order or dimension of a matrix. We can as well call it size of a matrix. It can as well be called size of a matrix. Size of a matrix. Yeah, size. So the order. So we can have the order of a matrix, dimension, and size of the matrix. So we have order and dimension of a matrix. So what is the order of a matrix? The order or size of a matrix is basically determined by the number of rows and columns that are found in the matrix. So as we have here, the order or dimension of a matrix is determined by the number of rows and columns contained in the matrix. So for example, when we have a matrix with R number of rows and C number of columns, so the order will be given as R by C. The sign here is called by, so it's called R by C. So that is let's look at a perfect example now. So just look at the 3 matrices we have here. We have the matrix here 1 and 2 and 3 examples, and the order is as follows. So these are the orders here. The order here is 2 by 3 because it basically contains 2 rows. So the rows are counted horizontally. So this is the first row and this is the second row. So 2 rows and then 3 columns. So it's 1 and we have 2 and then 3. So that is just basically the example. And as well we can so that is when we have 2 by 3, and here we have 2 by 2. The reason is that it's having 2 rows. Rows are counted vertically, horizontally rather. Rows are counted horizontally, and this is we have 2 columns as well. 1 columns are counted vertically. Alright, here we have 3 by 3. So we have 3 rows, horizontal counting, 3 rows. So we have 3 columns. So vertical counting is the columns. So that is just the idea of dimension. That is the idea of dimension. That is the idea of dimension, order, or size of the matrix. So it all means the same thing. So you can talk about dimension, the order and size of the matrix. So I think that is perfectly understood. So another areas, so we can have the basic type of matrices. So we have different type of matrices, and these are, we have the row matrix, a matrix with 1 row and multiple columns. That is what we call a row matrix. And this with 1 row and multiple columns is called a row matrix. Example is this. We have this matrix A. It's very important as well for us to know that matrix must be represented or must be defined with a capital letter or with a capital expression. So this matrix there is actually being defined by A So the matrix A, the order here is having just a single row and then 3 columns. So we can say the order is 1 by 3, a single row and multiple columns. You can see that the columns are more than one and the row is just one, so we call it a row matrix. Another type of matrix here is called column matrix. So if a row matrix is a matrix with one row and multiple columns, then a column matrix will be a matrix with a multiple row and a single column. So a matrix with multiple rows and a single column and one column is called a column matrix. So here we have three, because you can see we have 3 rows and just a single column. So the order is 3 by 1, just the inverse of that, the transpose of that, 3 by 1. So like that. Another type here we have rectangular matrix, and for a rectangular matrix, the number of rows and columns will not be the same. A matrix with the number of rows and columns are not the same. It's basically called a rectangular matrix. The number with unequal numbers of rows and columns. And for example, we can have a matrix A, which is 3, which is basically 3 rows and just 2 columns. So 3 rows and 2 columns, which is we can say that is 3 by 2. Another example we can have here is a matrix with how many rows? We have 3 rows, and 4 columns, and the other here is 3 by 4. So I think we can have some of this example. Let me erase this. So we have those examples there. So now we can move to another example, and here we have a square matrix. This is the opposite of the rectangular matrix, and it is a matrix with equal numbers of rows and columns. So it's having the same number of rows and columns. An example is when we have a 2 by 2 matrix. Look at it, having 1, 2 rows, 1, 2 columns, a matrix Q. Another example, when we have 3 by 3 matrix, 3 rows, 1, 2 and 3, 1, 2, 3. Alright, so another example here, we have a 0 matrix or null matrix, a matrix whereby all of its elements are zeros. Every element has zeros, so it's called a non or 0 matrix. Look at the matrix A, all of its elements are 0. The other here is 2 by 2. It's as well a square matrix. So we have this, and the example here is this. Look at every element has zeros. This is a matrix with order of 3 by 2. Alright, another type we have is unit or identity matrix, and it is a square matrix whereby is the element along the leading diagonals are usually 1, and the square matrix must be a square matrix, and every element at the leading diagonal must be 1, and 0 element will be as well. Look at the perfect example here. For a 2 by 2 matrix, we can have we have this 1 1 and 0 as well. This is the leading diagonal we have here. If we call this a leading, this is called the leading diagonal. This is the leading diagonal, and this 0 will be as well. Leading diagonal is this, and then 0 will be as well. So we have these are the leading diagonal. These are leading diagonal, and the 0 will be found there as well. Alright, so another example on that is for a 3 by 3 square matrix or identity matrix. We have this 1 1 or 2 at the leading diagonal and the 0 element as well. So take note that for identity matrix, we use these symbols to represent an identity matrix. If I should give you I I is 2 by 2. So I'm simply talking about an identity matrix of 2 by 2, and that will simply be this, an identity matrix of 2 by 2. That is what I'm referring to. So that will be 1 is 0 is 0 and then 1. So that's all right. So let's move to another section. So we can have addition and subtraction of matrices. Addition and subtraction of matrices. We have addition and subtraction of matrices. So the basic rule is that for you to add two or more matrices together, they must be of the same order. The order must be exact, must be the same thing. So the order must not be different if you have to add two or more matrices together. So you must ensure that they have the same order. So it means we can only add the matrices of order 2 by 2 with another 2 by 3 rather with another matrix of order 2 by 3. So that's just the simple rule. So it means we can never add this matrix of this order. We can add the matrix of which is 2 by 3 with matrix which is 3 by 2. The order are not the same, so you can't add or subtract them because they don't have the same order. So that is just the condition for matrix, for addition and subtraction of matrices. They must have the same order. Do not forget that. Alright, so that is just the simple rule. Let's take an example on that. So look at this example. You are given A, matrix A is this matrix here, 2, 3, minus 4, 5, a matrix of 2 by 2, and matrix B, which is 7, 8, 9, 5, a matrix of 2 by 2 as well. They must have the same order. The condition has been met. This means we can add and subtract them. So we are asked to find A, question A plus B, B minus A, and C 2A plus B, and D 3A minus 2A. Alright, so we have the solution. So we can simply have A, option A, and then we have the solution for A. Solution for A is that A plus B will be equals to, this is the matrix A here, as shown, plus matrix B, write that out, sum them, and that will be equals to, so the rule is that you just add the corresponding elements. So this element here, 2, is at the first row and first column. So this also is at the first row and first column. Just sum them together. So that will be 2 plus 7, 3 plus 8. Sum them together, the correspondingly, minus 4 plus 9, and 5 plus 5. Is as simple as that. So we can have our final answer. 2 plus 7 is 9, 3 plus 8 is 11, minus 4 plus 9 is 5, and 5 plus 5 is 10. So another example, B minus A, we have B now, and B, so we have that comes in. So we have A, B minus A, matrix B is this, so we have B, the minus the sign, and A, this is it here. So we can simply have 7 minus 2 as shown here, 8 minus 3 corresponding elements, 9 minus 4 as shown here, and 5 minus 5. So our answer will then be 7 minus 2 give 5, 8 minus 3 simply gives 5 as well, 9 minus 4, I mean 9 plus 4, because this will change to plus, next to negative sign will change to positive. So 9 plus 4 will give 13, and 5 minus 5 gives 0. Alright, so C, for C we have 2A plus B. So we have 2, which is simply a scalar element, plus multiplied by A, this matrix A, you write it out by the side as shown here, plus B, and you write a matrix B. Now the reason is that this scalar element of 2 will be used to multiply every element of matrix A first before we can sum. So multiply 2 by every element of matrix A before you sum. So 2 times 2 4, 2 times 3 6, 2 times minus 4 minus 8, 2 times 5 is 10. Then you can write your matrix B, and we can have our answer as that will 4 plus 7. You submit the corresponding element. 6 plus 8 as shown here, minus 8 plus 9 as shown there, and 10 plus 5. So 4 plus 7 gives 11, 6 plus 8 gives 14, minus 8 plus 9 gives 1, 10 plus 5 gives 15, and that is just that. So D now, we have D, and D is 3A minus 2A. Wow, minus 2B rather. This is actually B. Let me correct that. Do not mind that. So this is B. This should be B. Let me have that corrected. This should be B. 2B. Thank you. So this should be absolutely B. So we can write down. So we can have 3 multiplied by A, matrix A. So these are matrix A here. So this is scalar of 3. We use it to multiply every element of A, and minus the sign 2. Then you write your 2 here. Then matrix B. These are matrix B. So we can have 3 to multiply every element of matrix A. 3 times 2 is 6. 3 times 3 is 9. 3 times minus 4 is minus 12. 3 times 5 is 15. Minus 2 to multiply every element of matrix B. 2 times 7 is 14. 2 times 8 is 16. 2 times 9 is 18. 2 times 5 is 10. So we can simply subtract now. So 6 minus 14 as shown here. 9 minus 16 here. Minus 12 minus 18 as shown. 15 minus 10. So we can subtract now. So 6 minus 8 gives 6 minus 14 gives minus 8. 9 minus 16 gives minus 7. Minus 12 minus 18 gives minus 30. 15 minus 10 gives 5. So we can have that. So I think this is very simple to carry out. Alright, let's move to another. So I think we are still on addition and subtraction of matrices. So let's take another example on that aspect. Alright, so we have this example again. Given the matrices below, P is 14, 3, 2, 1, minus 3, 0. A matrix of that 2 by 3 is having 2 rows and it has 3 columns as shown. Also, this is another matrix Q, 1, 8, 9, minus 7, 3, 9. So it's having 2 rows. It's having 2 rows and 3 columns. So we have to find P plus Q and P minus Q. I think that is very easy. It's possible because they have the same order. We can add and subtract. Solution. So the first one, P plus Q. P plus Q will be equals to the matrix P as shown here plus matrix what? Matrix Q. So we can simply sum the corresponding element. That will be 14 plus 1 as shown. 3 plus 8 as shown, 2 plus 9 as shown, 1 plus minus 7 as shown here, minus 3 plus 3, and 0 plus 9 as shown here. So we can now have our answers to be 14 plus 1 is 15, 3 plus 8 is 11, 2 plus 9 is 11, minus 1 plus minus 7, 1 plus minus 7 is minus 6. Yeah, when you just you have in 7 and take away 1 from it, you have minus 6 left owing. So we have 3 plus minus 3 plus 3, that is 0. You own 3 and you have 3, that cancel, and we have 0 plus 9, that gives 9. So I think that is very easy. Now the second one here, where we have P minus Q. So P is shown here and minus Q is shown here. So we can have 14 minus 1 as shown, 14 minus 1, 3 minus 8 as shown, 2 minus 9 as shown. So 1 minus 7, yeah, minus 3 minus 3, 0 minus 9. So we can have our final answer to be 14 minus 1 is absolutely 13, 3 minus 8 is minus 5, 2 minus 9 is minus 7, 1 minus 7, this will change to plus, do not forget. Minus times minus gives plus. So that will be 1 plus is 7, that gives 8. Minus 3 minus 3, that gives minus 6. and 0 minus 9, that gives minus 9. So we can simply move to multiplication of matrices. So the simple rules of multiplication of matrices is based on conformability, rule of conformability. So we base, if you are to understand the aspect of multiplication of matrices, you need to understand the rule of conformability, and the rule say that the number of columns in the first matrix should be equal to the number of rows in the second matrix. Well, this is what I actually mean. Let's take an example on that, and then we can see what I actually mean by that. Look at this given matrix here, matrix A, and this is matrix B. So if the order of this matrix A here is of order 2 by 2, let me show that here, order 2 by 2. I'm coming. I think I will have something here. I will have something shown here. The order here is simply 2 by 2, 2 and by 2. Now the order of this here is 2 by 3, 2 by 3. So the rule of conformability says the number of columns in the first should be equal to the number of rows in the second. Alright, so let's take an instance whereby we have to find AB. So if we are to find matrix AB here, so matrix AB, whereby AB is the product of A times B. So your matrix A will be your first matrix, your matrix B will be the second matrix. So therefore, how can we know if they are actually conformable? The rule says that since matrix A is the first matrix, number of columns in the first matrix, how many columns does it have? 1, 2 is 2. Number of columns here is 2. First matrix 2, and should be equal to the number of rows in the second matrix. B is the second matrix. How many rows does it have? 1, 2. So it's 2. So it means they are equal. So now we have them equal to 2. So number of rows is equal to what? Number of columns. So that means conformability rule has been satisfied. So what happens? It's possible. Multiplication is possible. So we can multiply them together. So we can say multiplication is simply possible. So we can have them multiplied together. So it's possible to multiply. Alright, so in this time whereby we have to find BA, whereby we have to multiply B and A together. B is not the same thing as BA. So they are not the same. Just take that. For matrix multiplication, AB is not equals to, we are still going to talk about that later in our class, in tutorial. So it's not equals to BA. Yeah, it's not equal to BA. So just take that. Yeah, it's not equal to BA. Equals to BA. We'll talk about the rule that says that. So it's not equals to BA. So let's say if this is going to be conformable. So for our conformability rule, so B will become the first matrix now, and A will become the second matrix. So what are the number of columns in B? Number of columns in the first. Since B is not the first, how many columns does it have? It's having 3 columns. 1, 2, 3. So we have 3 here. Should be equal to number of rows in the second matrix. So number of rows in the second matrix. How many rows does the second matrix have? A is the second matrix. How many rows does it have? 1, 2. So are they equal? No, not equal. So we can have, that means they are not conformable. So therefore it is impossible to find BA. But AB is possible. So BA is not possible. Can we see that now? So if today we can find AB, let me show you something. If today we can find AB, we have a matrix A, and matrix B already, and we have to find AB. Order of this is 2 by 2. Order of this is 2 by 2. While order of this is 2 by 3, as the given example, 2 by 3. So we should know that to find AB for conformability rule. So find AB. We test for conformability rule. Number of column in the first. This is a column here. Number of column 2 should be equal to number of row 2. So since they are equal, we have them removed. So the new order of AB of the new matrix AB, its order would then be the number of row in the first, which is 2 by 3, and number of column in the second, 2 by 3. So the order of the new matrix AB will be 2 by 3. So that means it will use the number of row in A and number of column in B to be its order. So I think that is very, very easy. So you might be giving some example, you might be test on that later on. So I think that is understood. So let me erase the board. Coming. All right. So now let's look at another aspect example on that. All right. So we're given that A is matrix A is equals to this 1 minus 4 2 4 0 1, and matrix B is equals to 2 0 minus 4 minus 3 1 minus 2. We are asked to find AB. So let's test for conformability rule. So AB, A, and then B. So what is the order of matrix A? We have 2. How many rows does it have? 1 2. How many column? 1 2 3. So that will be 2 by 3. So we have 2 by 3, 2 by 3 to be the order. How many rows does this have? 1 2 3. How many column? 1 2. So that will be 3 by 2. So we have 3 by 2, 3 by 2. So conformability rules. To find AB now, for AB, this is the first, A is the first, and this is the second. So number of columns in the first, the number of rows is the second. I think we have that already. So for matrix AB, its dimension, or size will simply be 2 by 2. 2 by 2. So its dimension will be 2 by 2. So we can have the solution. That's the dialectic test for conformability rule. All right. So for AB, we can solve that now. We have AB. So we can multiply this our A multiplied by matrix B. All right. To solve that, so it's very easy. What you just need to do now is you will take it step by step. It's unlike addition. It's not 1 times 2. No. It's not like addition. So what you just need to do now is for you to use the first row to multiply the first column. So we can have first row to multiply the first column. That will be 1 times 2. That give you plus 1 times 2. This is it here. Then minus 4 times 0. You can see 2 times minus 4. You can see. So once you are done with that, then you as well multiply your second row. No, sorry. So once you are done, you as well use the first row. You as well use the first row. I'm coming. You will as well use the first row to multiply the second column as shown here. So that will be 1 times minus 3 as shown. So this by the time we multiply and sum all of this, that will simply give us our first row in the matrix AB. So to get this first row first column, with sum of that will give us first row first column of the element. That will give us the element of first row first column. So of AB of matrix AB. So to get the element of first row second column, so you have said that the first row second column. So you need to multiply the two together. 1 times minus 3 plus minus 4 times 1, 2 times minus 2. So I think that is well understood. As well, also to get the element of second row, first column, we have second, these are our second row, yeah, and first column. So we multiply each of the elements together. 4 times 2 is 0 times 0, 1 times minus 4. I think that is well understood as well. So as well, also to get the element of second row, first column, second column rather, so you multiply these two together as well. So we have 4 times minus 3 is 0 times 1, and 1 times minus 2. I think that is well understood. So let's move on. So we can then have 1 times 2. We know how we got all of this. That is, it has been explained. 1 times 2 is 2. 4 times minus 4 times 0 is 0. 2 times minus 4 is minus 8. 1 times minus 3 is minus 3. 4 minus 4 times 1 is minus 4. 2 times minus 2 is minus 4. 4 times 2 is 8. 0 times 0 is 0. 1 times minus 4 is minus 4. 4 times minus 3 is minus 12. 0 times 1 is 0. And 1 times minus 2 is minus 2. So we can have our final answer to be 2 plus 0 plus minus 8 is absolutely minus 6. Minus 3 plus minus 4 plus minus 4 is simply minus 11 if you sum that. Yeah, so 8 plus 0 plus minus 4, that gives us 4. You can sum that using your calculator, or if you are fast at calculation, calculating numbers, you have simply get that. So minus 12 plus 0 plus minus 2, that gives us minus 14. I think we are done on multiplications. So yeah. Alright, so we have to find as well, find BA. We are asked to find BA. So let's text if BA will be possible. So let's still apply our conformability rule to check if BA will be possible. So we have to find BA. So B will be the first matrix this time around. So what is the order of B? B is 3 by 2 as shown. 3 by 2. And what is A? A is 2 by 3. 2 by 3. And the rule says the number of row, it is number of column in the first. B is not the first matrix. Number of column in the first should be equal to number of rows in the second. So this will be the dimension of BA. Dimension of BA will be this now. So BA matrix BA, its dimension is simply 3 by 3. So this is its dimension, 3 by 3. Alright, so we are asked to multiply this, so we're still using our rule. So we have a matrix of 3 by 3 as shown here. So the matrix will be 3 by 3. So you take the first row, yeah, to get the element of every element of the first row, to multiply each of the column element here. Use first row to multiply the first column to get the element of the first row, first column. 2 times minus 3. 2 times 1 is, we have that. Minus 3 times 4, we have this. So we also use it to multiply the second. This is to multiply the second column. 2 times minus 4 here, minus 3 times 0 is here. So also use it to multiply the third column. So since it's conformable, we'll be able to multiply 2 times 2 is 2 is 4, minus 3 times 1, we have that shown here. So let me clean the board. Coming. So also to get every element as the second row of matrix A, take the second row of BA, of matrix BA. So we can use second row here, 0, 1, second row of B to multiply every column of A. So 0 times 1, 1 times 4. We do the same thing here as well. 0 times minus 4 as shown there, then 1 times 0 as shown there. So use it to multiply the third column. 0 times 2, so 0 times 2, this is supposed to be 2, it should be an error coming. This should simply be an error. So this will be an error. So this should be 2 times 2. So we can have that. So 1 times 1, we have that already. Alright, so let me erase that. So that aspect has gone. Now the last aspect now is we trying to explain the last row of the matrix BA. So use the third rows of B to multiply every columns of A. So first column minus 4 times 1 minus 4 here, then minus 2 times 4, we have it here. So use it to multiply the second column as well. So minus 4 times minus 4 as shown there, then minus 2 times 0 as shown there. Use to multiply the third one as well. Minus 4 times 2 as shown, then minus 2 times 1 as shown here. So let's simply guess the answer. So we can have that here. So 2 times 1 is 2, minus 3 times 4 is minus 12, and plus and minus will be minus. That will be 2 minus 12. 2 times minus 4 is minus 8, plus minus 3 times 0 is 0, so the plus will not change. 2 times 2, 4, minus 3 times 1 is minus 3, plus and minus, that will be minus 3. So 0 times 1 is 0, 1 times 4 is 4, 0 plus 4, 0 times minus 4 is 0, 1 times 0 is 0, so we have 0 plus 0. 0 times 2 is 0, 1 times 1 is 1. Here, minus 4 times 1 is minus 4, minus 2 times 4 is minus 8, plus and minus, that will be minus 8. So we have this. So minus 4 times minus 4, that will be plus 16. Minus times minus is plus. 4 times 4 is 16. Plus 4 is 16. Minus 2 times 0, that will give us 0. We have it here. And minus 4 times 2, that will be minus 8. Minus 2 times 1 is minus 2. Alright, so we can have our final answer. 2 minus 12 is minus 10. Minus 8 plus 0 is minus 8. 4 minus 3 is 1. 0 plus 4 is 4. 0 plus 0 is 0. 0 plus 1 is 1. Minus 4 minus 8 is minus 12. 16 plus 0 is 16. Minus 8 minus 2 is minus 10. Alright, so just go through it. You can pause the video to watch this around and see how it's being explained again. So the section we have now is, okay, we are still on multiplication of matrices. Let's take another example on that. Alright, we have matrices P and Q. Matrix P is 3 by 3, Q is 3 by 3. We have to find PQ. Alright, it's fine. So you have the same order. Automatically they will be conformable. So P, they will be conformable. PQ, order here is 3 by 3, 3 by 3. I'm coming. 3 by 3, and then we have 3 by 3 as well here. So number of column is the first, the number of row is the second. So automatically what happens? The matrix, the order of PQ, will be equals to 3 by 3 as well. Order of PQ will be 3 by 3 as well. Alright, so we have PQ to be this. This is P and this is Q. So do not forget our row. We use the first row here to multiply every column of the second matrix first. So let's have a display of it. So we have 1 times 1 shown here, plus minus 1 times 0 as shown here, minus 1 times 8 as shown. Now let's move to that will be first row, second column. Now this is it here. So 1 times 5 as shown, minus 1 times minus 4 as shown, 1 times 1 as shown. So first row, third column, 1 times 3 as shown, minus 1 times 1 as shown, 1 times 5 as shown here. Alright, so that has gone. Another aspect we can take the second, these are second row, which is to multiply every column as well, every column of a q. So we use that to multiply every column of matrix q. The second matrix, minus 3 times 1 as shown here, 2 times minus 4, okay, 2 times minus 4, minus 1 times 1, sorry, minus 3 times 1, 2 times 0, do not mind me, that's a very big error. First, to multiply the first column, we are still here. So minus 3 times 1 is here, 2 times 0 is here, minus 1 times 8 is shown here. Alright, so minus 3 times 5 is shown, 2 times minus 4, minus 1 times 1 is shown here. Alright, so minus 3 times 3 is shown, 2 times 1 is shown here, plus minus 1 times 5 is shown. Alright, so the next thing is as well, we take the third, we can as well take the third row to multiply every column. The first column, use it to multiply the second column, and as well the third column. Alright, so minus 2 times 1, so minus 2 times 1, we have it here, 1 times 0 is here, 0 times 8 is shown here. So minus 2 times 5 is here, 1 times minus 4, and 0 times 1 is shown here. Minus 2 times 3 is here, 1 times 1 is shown here, and 0 times 5 is shown here. Alright, so we can have that 1 times 1 is 1, 1 times minus 1 times 0 is 0, that plus 0, 1 times 8 is 8, so we have the sum. 1 times 5 is 5, and 1 times minus 4 is plus 4, so we still have plus 1 times 1, so we have this. 1 times 3 is 3, minus 1 times 1 is minus 1, 1 times plus will be minus, do not forget. 1 times 5 is 5, that is written as plus. So here minus 3 times 1 is minus 3, plus 2 times 0 is 0, minus 1 times 8 is minus 8, we have this. So minus 3 times 5 is minus 15, 2 times minus 4 is minus 8, we have minus here. Minus 1 times 1 is minus 1, so that will change to minus. Minus times plus is minus, we have this here. Minus 3 times 3 is minus 9, plus 2 times 1 is 2, minus 1 times 5 is minus 5, so that will change to minus, we have this. So minus 2 times 1 is minus 2, 1 times 0 is 0, that will be plus 0 times 8 is 0, so we have this in sum. Minus 2 times 5 is minus 10, plus 1 times minus 4 is minus 4, so that will be minus as well, plus 0 times 1 is 0, minus 2 times 3 is minus 6, we have it here. 1 times 1 is 1 in sum, plus 0 times 5 is 0, so we have this. So we can then get our final answer. So therefore PQ will be 1 plus 0 plus 8, that will be 9, 5 plus 4 plus 1 is 10, minus 3 minus 1 times 5 plus 5 rather. So we have here is 7, so it's minus 3 plus 0 minus 8, that will give us minus 11, minus 1 minus 15 minus 8 minus 1 is minus 24, minus 9 plus 2 minus 5, that will give us minus 12. If you sum that, you can use the calculator. Minus 2 plus 0 plus 0, that will be minus 2, minus 10 minus 4 minus 4 minus 0 plus 0, that will be minus 14, minus 6 plus 1 plus 0, that will be minus 5. So we have this as our final answer. So this is matrix PQ. We will multiply. Do not forget, complementability will be applied by matrix. Alright, so another aspect now is now transpose. So what is the meaning of a transpose of a matrix? When are we to transpose? What does it mean to transpose a matrix? It means to change the order of a matrix, to inverse it, to interchange the number of rows and columns, to interchange the rows and columns of a matrix. So the rows become column become rows. So the symbol for transpose is we use prime, this symbol is prime, or you can use T. So transpose of the transpose of a matrix A is this A raised to power T, or A prime. So it means transpose. So that means you are expected to interchange the word, the column and row. So find the transpose of each of the matrix A. We have matrix A to be this, which is, what is the order? Let's write the order out. For matrix A, the order is 2 by what? 2 by 3 is having 3 column. Use 2 by 2 as well. So this is now the order here is 3 by 3. So matrix C is 3 by 3. Let's look at our final answer. Solution now. So we have matrix A now. So this is matrix A. Then its transpose is now this. So that means this now become this. The first row become the first column now. We have transposed this. So this is the symbol. The second row becomes the second column. It has been transposed. I think that is well understood. And the other will then become 3 by 2. Yeah, because the row will now become 3, the column will now become 2. So we have transposed. We have look at before transpose was 2 by 3. Now it's now 3 by 2. All right, another example. The first one, so we have matrix P. This matrix B, which is 2 by 2, and then a transpose is this. This become this now, and the second row become the second column. Right, so it still remains as 2 by 2 since it does not change. It's having the same number of row and column, so it still remains as 2 by 2. So for C, so this is absolutely matrix C, and the transpose is this. So the first row, we have this to be the first column here. The second row, we have this to be the second column here. And the third row, we have it to be the third column. So we have transposed, and this should remain as 3 by 3. Why? Because it's a square matrix, so it's not changed. So we have this to be the same thing. So if for a square matrix, when we find transpose, the dimension does not change. But for a non-square matrix, a rectangular matrix, the dimension interchanged. Do not forget, the size changed. The size of the matrix will change by the time we find the transpose for a rectangular matrix. That is all about transpose. So we can move to determinant. So what is determinant? Determinant is just a scalar element, or a scalar quantity, which is being derived by manipulating the element of a square matrix. So we derive by trying to manipulate, do some kind of manipulation on the square matrix. We can get a scalar element, which can be helpful a lot. It can really help us. It can help us. So from a square matrix, so it means a non-square matrix can never have a determinant. Just get that. So for determinant, we use the symbols to represent determinant. 2 stroke line. This is not a bracket. Don't forget. So you can use its word itself, determinant, just from det and the bracket. So maybe let's say we want to find the determinant of A. So A will be found there. It means find the determinant of A, or we have this. So that's one that is going to be a single quantity, a single element. So determinant of A. So that's how to let us the notation for determinant. Alright, so that is the notation for determinant. So we have this as the notation for determinant. Do not forget. So let's look at how to find the determinant of a 2 by 2 matrix. So this is being given here. To find the determinant of a 2 by 2 matrix, if you have a matrix A, which elements are A, B, C, D. To find the determinant of A, it will be you multiplying the major diagonal, this AD together, minus you multiplying this together. So A times D minus B times C. So you multiply this. I just the idea. Let's take an example. And find the determinant of the following matrices. Matrix A is this, matrix B is this. So solution, to find the determinant of A, the determinant of A will be simply be 2 times 5 as shown, minus 4 times minus 3, or minus 3 times 4, anyone. So we can have 2 times 5 is simply 10, minus 4 times minus 3 is minus 12, minus times minus will be plus, and that will give us 22 to be the answer for that. And for B, we can have that the amount of B to be equals to 1 times 5 here and 0 times 4. So 1 times 5 is 5 minus 0 times 4 is 0, and that will give us the answer to be 5. Alright, so the determinant of a 3 by 3 matrix now. Let's move to that aspect. To find the determinant of a 3 by 3 matrix, it's very easy. Let's take an example as well. So if we find the determinant of, this is matrix A, we have the matrix to be this, matrix A. Find the determinant of matrix A, which is this we have 2, 7, 3. To find that is very easy to find out. What you just need to do is you can just take any row, any column. So let's use the first method here that's always been used. So you can just take your first row here, the element at the first row. So and the sign is that we have plus here. So the first row element here is take a positive sign, this take a negative sign, and this take a, we explain that by the time we get to the aspect of minor and cofactor. So this take a positive sign at the first row. So you can just start plus 2 multiply by, to find the determinant of A, the determinant of A will be that as I'm explaining, just follow me, will be equals to, so you take your first row, its sign is positive, so that will be plus 2 or 2. So now delete the element here. So after you have done that, delete the element here, delete the element of elements, all the elements at the row and column of 2. So this is the row of 2, delete it, and this is the column, delete it. So what do we have left? We have 5, 8, 1, and minus 3. So here we have 5, 8, and 1. Oh my god, I'm coming. So and then 1 minus 3. So we have that. We have formed a 2 by 2. I will be 2 times this 2 by 2 matrix, this determinant of this 2 by 2 matrix. Now what is the sign here? Minus. So minus, what is the element here? 7. Minus 7. Now what we just need to do now, after that, let me erase this. So now we have the element 7 now. The sign is minus, so minus 7 has written that. So we have a 2 by 2 matrix now as well, plus 9. So the sign is plus 9. Let me show that. Plus 9. The 2 by 2 matrix follow as well. So now all we just need to do now is we need to delete this is matrix element 7 here, but we delete every element that is row and every element that is column. So as done here earlier. So what do we have left? We have 3. So you 3 here, 3, and 8 here. So we have minus 2, minus 2, and then we have minus 3, minus 3. Alright, so yeah, same thing applies to this place as well. So yeah, we have 9 now. Delete is every element that is row and every element that is column. This is column. So what do we have left? We have 3, 5, and we have minus 2, and we have 1. So we can find this. I think that must have been shown. So we have the solution. So we have that now. So I think I've explained every step here. It has been explained already. It has been explained. I've explained that perfectly and how this is being derived. So you can just take the video back forward. So once we've got that now, so get the determinant. So we have 2, so we need to multiply these 2. That is become a 2 by 2 matrix, and multiply this. So 5 times minus 3 minus 15, 1 times 8 minus 8, so minus 7, minus 3 times minus 3, that will be minus 9, minus 2 times 8, that will be minus 16, minus times minus, that will be 16. Let me show you. This is how it was actually being derived. So here we have 5 times minus 3 minus 1 times 8, that is for the first aspect, and that was 5 times minus 3 is absolutely minus 15, and here 1 times 8 is 8, so minus 8. So that's how they got that. And for this place, here we have 3 and times minus 3, so minus 2 times 8, so 3 times minus 3 is 9, so that's why we have minus 9 rather, we have minus 9 here. So minus 2 times 8 is minus 16 here, and minus times minus, there will be plus, that will be plus 16 as shown here. So plus 9, do same here as well. So here we can therefore have 3 times 1, so my 3 times, we can therefore have 3 times 1 minus 2 times 5, so yeah, 3 times 1 is 3, we have it here, minus 2 times 5 is 10, minus 10, and minus 10 here, and we can have minus times minus, that will be plus 10, so 3 plus 10. Alright, so I think that is one. So that's how that everything there was derived. Let me erase everything here. I think you get that perfectly, just to enhance your understanding. So we can have now, so minus 15 minus 8, that will be minus 23. We have minus 22 times minus 23. We have minus 7 here. Then minus 9 plus 16, that will be 7. So plus 9, 3 plus 10 is 13. So we can have now 2 times minus 23 is minus 46. Minus 7 times 7 minus 49. 9 times 13, 117. Use your calculator. So sum everything here, we have 22. So the determinant is 22. So we have, although we have other way, a faster way, and that we call it the Cyrus, using the Cyrus method, finding the determinant using the Cyrus rule of determinant. So it's very, very fast. So since we have a matrix A and we have to find the determinant of A, so therefore, so repeat the first 2 columns at the right hand side. So this is the first 2 columns at our right hand side, at the right hand side. So this is the first 2 columns here. Repeat it at the right hand side as shown below. So we have it here. So first of all, this is the matrix we have to find the determinant. Write everything out and repeat the first 2 columns, 1 and 2. So the first 2 columns at the right hand side as shown there. So next thing we need to do now, first we will then group. Start with at the major diagonal of the first matrix. Group in 3. Group them in 3. Yeah, downward first. I'm sorry. Let me make it perfect. So you group them. You try to group them in 3 now. You try to group them in 3. So we have then group of 3. So now you have to multiply them now. as shown. So we have downward minus upward, downward product, upward product. So downward product, that is what I've shown you. So first thing we need to do now is multiply this now. 2 times 5 times minus 3 as shown, plus 7 times 8 times minus 2 as shown here, plus 9 times 3 times 1 as shown here. So this is what we call downward product. So you multiply and sum them. So everything here is our downward product here, and everything has been put in sum. And let me show you upward now. For upward product now, we can have, this is how it goes. Group of 3, this is our upward product. I think we have done a perfect job. So we have minus now, minus upward product, minus 2 times 5 times 9 as shown here, plus 1 times 8 times 2 as shown here, plus minus 3 times 7 as shown here. So we can have that now. So let's, here is 2 times 5 times minus 3 is minus 30. So 7 times 8 times minus 2 will be minus 112, and here minus times plus will be minus. Here 9 times 3 times 1 is 27, and that will still remain at plus, is not negative. So this is everything here, product of all downward multiplication, and we have to sum them now. So minus product of all upward product now, sum of all upward products, sum of all upward products. So here we have minus 2 times 5 times 9, that will be minus 19, plus 1 times 2 times 1 times 8 times 2 is 16, that will be same, plus minus 3 times 7, that will be minus 63. So minus 63, we have that. So we can then sum all upward, all downward product now, sum them, and that will simply give us minus 115. So minus sum all upward products, sum them together, and that will give us minus 137. So, and then we can have our final answer. So here we can have minus 115, which is the sum of all downward products. So minus and minus, that will be plus sum of all upward products. So we can then sum, and that will give us 22 as our final answer. I think that is very easy. So that is what the rules of Cyrus. It's very easy and faster in getting it done, if you can understand that. Now let's move to the aspect of cofactor and adjoint of a matrix. Okay, example. So to get cofactor, to get adjoint, the first step that you need to do, or you need to know, to actually move to the aspect of inverse of a matrix. So let's see how to determine cofactor and adjoint of a matrix. So but before we will be able to get the aspect of cofactor, we need to know how to get what we call minor of a matrix. Minor of a matrix is that the aspect is that every element, we need to understand the aspect of minor. We need to aspect is that every element of a matrix has a minor. 2 has a minor, 1 has a minor, 7 has a minor. 8 of this matrix has its own minor, minus 1 has its own minor, 0 has its own minor, 1 has its minor, 9 has its minor, 2 has its minor. Every element here has their minors. And how do we get the minors of a particular element? So you get the minor of any element, or it must be a square matrix, is that the determinant of a remnant element after deleting the row and column of that which that element belongs to is the minor. But I state again, the determinant of the remnant of what? Of a particular element after its row and column has been deleted. The determinant of the remnant is its minor. So to find the minor of 2, for instance, we need to delete its row and column. So the determinant of this now will give us its minor. As well, to find the minor of 1, we need to delete its. To find the minor of 1, we need to delete its row and its column. Its minor will be 1, determinant of 8, 0, 1, 2. I think that is very, very easy. So every element has their minor. So to get cofactor first, we need to get what we call minor, and that is what we actually did here. So first of all, we simply delete we find the minor of each element, so put that in a single matrix, so it is here. So the minor of this will be minus 1 0 9 2. This is it here. All right, so the second matrix as well, to find the minor of the second, you have to delete its row and its column. I think that is well understood. What do we have? We have 8 0 1 2 is shown here. Same thing next. To get the minor of the 7, you need to delete its row. So the row of 7 is this, and its column. So what do we have left? 8 minus 1 1 9. So this is here. All right. So to get the minor of getting the minor of 8, you need to delete its row. This is row here, and its column. So what 1792 as shown here as well. Again, to get the minor of getting the minor of 5 of minus 1 rather, delete this row and then this column. 2712 2712, that has gone. Also, to get the minor of 0, we have to delete this row and delete this column. We have 2119 2119. So you continue that way, you'll be able to get the minor because of time. All right, so delete the row and column to get the minor of 1, this and this to get the minor of 1 7 minus 1 0. We have it here. To get the minor of 9, it's row column 2 7 8 0. The minor of 2 is row and column 2 1 8 minus 1. So that's shown here. So we'll find the determinant of each now. To find the determinant of each, then we can just say we have minus 1 times 2 minus 2 minus 9 times 0 is 0. So we go 2 times 8 is 16, 1 times 0 is 0, 16 minus 0, we go that way. 8 times 9 is 72, minus 1 times minus 1, that will be minus 1, minus times minus, that will be plus. We have this. So 1 times 2 is 2. You can pause the video and try to do the rest yourself. You have this. Try to pause the video, you will have, so you can do some calculation yourself because of time. We have everything like that. So we'll find the subtraction, we subtract each for each, so we are able to arrive at this matrix here. So this is the minor of this matrix, so we'll be able to get the minor. Now to get the cofactor now from the minor, we need to get this idea. For every square matrix, each has its sign. Yeah, each has its sign. Each element has the signs. All right, for every square matrix. So since they have their minor, they also have that sign. For a 2 by 2 matrix, so this is for 2 by 2, and it's very very easy to master. Just a little intuition, so you'll be able to get that. This is for 2 by 2. So this is for 3 by 3. We have 3 by 3, and this is for 4 by 4. 4 by 4. So for 2 by 2, we have plus minus minus plus. For 3 by 3, plus minus plus minus plus minus. You can use it to play plus minus plus. We begin with plus above. So plus, they have minus plus. We begin minus now, minus plus minus, then plus minus plus. So here we have plus minus plus minus, then minus plus minus plus. So plus again, minus plus minus. You begin with minus plus minus plus. So you begin with plus here, you continue that way. You begin with minus now next. You continue that way. You begin with plus here. You begin minus here. You continue. So here you begin with plus, continue that way. You begin with minus, continue. Begin with plus. So it's easy like that, and so on and so forth like that. So once you can get that, and you can get each element, since now what we are dealing with now is a 2 by 2 matrix. So let me so the 2 by 2 matrix, we have to apply this now. We should begin to apply this now. So you apply this sign on every element to get your cofactor. So these are cofactor now. So plus is for the first element, as we are able to do that the other time. So plus, so plus times minus 2 minus times 16 plus times 73 minus times minus 61 plus times minus 3 minus times 17 plus times 7 minus times 56 plus times minus 10. So we have that now at the one side. Plus and minus is 2 minus 2 minus times 16 is minus 16 plus times 73 is 73 minus times minus 61 is 61. So minus times minus is plus. You know that plus times minus 3 is minus 3 minus times 17 is minus 17 plus times 7 is 7 minus times minus 56 is 56 plus times 7 minus 10 is minus 10. So we have this as our cofactor. These are cofactors. So don't forget, get a minor until after you get cofactor. Now we have to get adjoint. Now what is not adjoint? Adjoint is simply the transpose of cofactor. Again, let me write that. Adjoint, your adjoint, adjoint, your adjoint, the adjoint is transpose I think you know what transpose is now. So it's transpose of cofactor. So to get our adjoint now, we have to transpose the cofactor. So transpose of cofactor. So every row will become column now to get the adjoint. So this row now become column as shown here. So this row become the second column as shown here, and this third row become the third column as shown here. So we are able to get our adjoint. That is the idea of cofactor and adjoint of a matrix. The inverse of a matrix. So what is the inverse? How do we define inverse of a matrix? So inverse of a matrix A or any matrix is divided by raised to power minus 1. I should know it. Inverse of any number is raised to power minus 1. And that's usually defined as follow. Inverse of matrix A will be 1 divided by determinant of A multiplied by adjoint of A. We know how to find adjoint. So once we divide the adjoint by the determinant, we get our inverse. So we know how to find the determinant as well. So let's find the inverse of the previous example. And what is the example? So we need to find the determinant of the matrix first. We don't need the determinant, and the determinant is you have to delete the row and column, and if you and you can be able to get that. So we can be able to get that. So we multiply this and this, we get this. We multiply this and this, we are able to get the first one, and this we are able to get that. So we'll be able to get that. All right. So multiply this minus 76 and this, you'll be able to get plus and the sum that. So we'll be able to simplify the expression. I don't want to explain much. So we can multiply this and this, and we are able to get the determinant. The determinant is 491. Alright, so of the matrix. So this is an adjoint. We solve the adjoint. You can revise the video. You can as well revise the video to get how this is solved. I think I explained. You can use your scenarios as well to get the determinant. Just get the matrix out and get the determinant yourself. And the adjoint is solved. Just take the video backward. How we solve the adjoint. So our answer will then be inverse will then be, therefore our inverse will be 1 over the determinant. The determinant is this. So multiply by the adjoint. It's simple. That's just the inverse of the matrix. So thank you. I think you enjoyed the class. So you have some practice questions to try to solve everything. Please take your time, pause the video, and I need the answer so you can contribute on the group. So you can send your answer, send your view. I'll be anticipating your answers so you can solve that together. Take your time, go through them, pause the video, try to solve each of them. So go through them. You can simply pause the video, solve them. I need the answer as soon as possible on the group so we can communicate together. Do not let this be the poor response on exam and logarithms. I need the answer to this. Try to practice them minute on minute and solve them. Thank you so much.